Hello children, how are you? Today we are going to do class 10 chapter 9 applications of trigonometry. Children, in chapter number 8, that is introduction to trigonometry, you have already done what are T ratios or trigonometric ratios. Let us quickly recapitulate them. Trigonometric ratios are always used in a right angle triangle. Like here I have drawn a right angle triangle which is right angled at point C. And I have taken an angle here, that is angle B, whose measure is equal to theta, which is a variable. Now with respect to this angle theta, this is the perpendicular, this is the base, and this is the hypotenuse. The longest side in a right angle triangle is hypotenuse. So which are the trigonometric ratios? First ratio that we did was sine theta. Sine theta is defined as perpendicular upon hypotenuse. So here the perpendicular is AC upon hypotenuse is AB. So sine theta is equal to AC upon AB in this triangle or perpendicular upon hypotenuse. So cos theta, it is defined as base upon hypotenuse. So here in this triangle it is BC upon the hypotenuse, that is AB. Tan theta is equal to, as you have already done, perpendicular upon base. So AC upon BC. Now we have three more trigonometric ratios. Sin theta, inverse of sin theta is cosecant theta, which is defined as hypotenuse upon perpendicular, and we can write it as AB upon AC. Inverse of cos theta is secant theta, which is hypotenuse upon base, and you can write it as AB upon BC. Similarly, inverse of tan theta is cot theta or cotangent theta, which is defined as base upon perpendicular, and in this triangle for angle theta it is BC upon AC. So these are all the 6 trigonometric ratios that we studied in the last chapter, and we will be studying here also. Now children, you must be wondering where and how these T ratios are used in our daily life. Let us quickly discuss that. Children, trigonometry was invented because of its need in the world of astronomy. It has been used to calculate distance of Earth to the planet and stars, to construct maps, to determine position of an island in relation to longitudes and latitudes. Children, do you know that in 1852, a large surveying project, Great Trigonometric Survey, was conducted, for which 2 largest ever theodolites were built. Now what is a theodolite? Theodolite is a surveying instrument which is based on principles of trigonometry and is used for measuring angles with a rotating telescope. Using theodolites, the highest mountain in the world was discovered, which was later named in 1856 after Sir George Everest. So children, let us understand how we can use trigonometry in daily life situations. For this we need to understand a few terms. Look at this figure. There is a person who is looking towards the top of the tower, that is point C. The line AC joining the eye of the person to the top of the tower is called line of sight. So the line drawn from the eye of the observer to the point in the object viewed by the observer is called line of sight. In the figure, angle BAC is called angle of elevation. So angle of elevation of the point viewed is the angle formed by the line of sight with the horizontal when the point being viewed is above the horizontal line. That is the case when we raise our head to look at the object. Now what if we don't look upwards, but we are at an elevated place and we look downwards? Say in this picture, a girl is sitting on the balcony and looking down at a ball on the ground. Here the line of sight is below the horizontal line. The angle so formed by the line of sight with horizontal is called angle of depression. So we can say that angle of depression of a point on the object being viewed is the angle formed by the line of sight with the horizontal when the point is below the horizontal level. That is the case when we lower our head to look at the point being viewed. So let us understand in which cases trigonometry helps. Suppose you want to find the height of a very tall building or a tower. You cannot do that with the help of a measuring tape. So if you observe it at a distance from the ground, like here, to find the height of this tower, you need to know three things only: distance DE, angle of elevation BAC of the top of the tower, height AE of the observer, and of course the knowledge of trigonometry. So let us do such questions which demonstrate how we can use trigonometry in real life situations. Children, let us discuss the question. A contractor plans to install 2 slides for the children to play in the park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree to the ground. Whereas, for elder children, she wants to have a steep slide at a height of 3 meters and inclined at an angle of 60 degree to the ground. What should be the length of slide in each case? So children, here we are given that we have to construct 2 slides. One for the children below 5 years of age and another for the elder children. Now the angle of inclination for the first slide is only 30 degree, whereas angle of inclination for the second slide is 60 degree because it can be a little steeper also for elder children. Now height of this slide above the ground is 1.5 meter and this slide is 3 meters. We have to find the length of the slide in both cases. Now here if we look at this triangle, this is clearly a right angle triangle at B because this is we are talking about a vertical line. So here in this triangle we can apply trigonometry. We know the angle 30 degree. With respect to this angle, this is the perpendicular, this is the base and this is the hypotenuse. Now which T ratio connects this perpendicular with the required length, that is hypotenuse? Children, which T ratio is it? It is sine. So sine 30 degree is equal to perpendicular upon hypotenuse, which is equal to AB upon AC. Now what is the value of sine 30 degree? Quickly revise it in your mind. It is half. And AB we know that it is equal to 1.5 upon AC. If we bring AC here, we get 2 into 1.5. That is 2 multiplied by 1.5 will give us 3.0. This is in meters because 1.5 was given in meters. So we got that the length of this slide will be equal to 3 meters. Now what about slide 2? Now in case of slide 2, again we are given this angle, and with respect to this angle, this is perpendicular, this is base and this is hypotenuse. So which T ratio connects this side which is given, that is perpendicular, with the hypotenuse that we have to find? That T ratio is again sine. So sine of 60 degree is equal to perpendicular upon hypotenuse, and in case of this triangle, its name will be PR upon hypotenuse is PQ. Let us put the values. Sine 60 is root 3 upon 2. PR is 3 and PQ is unknown. Let us find PQ. Bring PQ to this side. We get 3 into 2 upon root 3. Let us rationalize the denominator. When we rationalize the denominator, we get into root 3 upon root 3. So 6 root 3 upon 3. So this is 2 root 3 meters. So the length of this slide, the second slide which is to be built for elder children, should be 2 into root 3 meters. Now let us do another question. A statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degree, and from the same point, the angle of elevation of the top of the pedestal is 45 degree. Find the height of the pedestal. So children, according to the given situation, I have drawn this figure. This is the length of the pedestal BC and this is the statue mounted on it AB, which is equal to 1.6 meter. The angle of elevation of the top of the pedestal is 45 degree and the angle of elevation of the top of the statue is 60 degree. We have to find the length of BC, that is the length of pedestal. So BC is unknown, AB is known to be equal to 1.6 meter. So how will we find this? We can see that there are two triangles, right angle triangles. One is triangle BDC, right angle at C, and here angle 45 degrees given. And the other triangle I can see is triangle ADC, which is also right angle at C. So in both the triangles, the trigonometric ratios are applied. So let us start with triangle BDC. In triangle BDC, tan 45 degree will be equal to perpendicular upon base, right? Which is equal to BC upon DC. So what is the value of tan 45 degree, children? It is 1. So 1 is equal to BC upon DC. So I can say that DC is equal to BC. So I write this as statement number 1. This DC is equal to this BC. Now take the bigger triangle. In triangle ADC, tan 60 degree, which is again perpendicular upon base, but in this bigger triangle, the perpendicular is AC, whole of it. The base remains the same, that is DC. What is the value of tan 60? Tan 60 is √3. Now AC is made up of two parts, AB and BC. So I can write this as AB plus BC upon DC. Now out of the two things, do we know the value of anything? Yes, we know the value of AB. So I can write √3 is equal to 1.6 plus BC. Now if I write here DC, we already know that DC is equal to BC. So can I replace it? Yes, using statement 1. So you can see that this is an equation with only one variable, that is BC, which is unknown. Let us try to solve this. √3 BC is equal to 1.6 plus BC. So I take all the terms with BC as variable on one side and keep the other to the other side. I can get, so if I take BC as common, I get this. So BC is equal to 1.6 upon √3 minus 1. I can rationalize this denominator, right? So I will rationalize this by multiplying with √3 plus 1 and dividing with √3 plus 1. I get 1.6 bracket √3 plus 1 upon √3 square minus 1 square, that is 3 minus 1. So 1.6 √3 plus 1 upon 2. On dividing, I get 0.8 bracket √3 plus 1 meters. So this is the answer, that is BC, the length of the pedestal. This comes out to be equal to 0.8 √3 plus 1 meters. Let us do another question. From the top of a 7 meter high building, the angle of elevation of the top of a cable tower is 60 degree and the angle of depression of its foot is 45 degree. Determine the height of the tower. So children, here we are given two things. One is the building, another is the tower. From the top of the building, the angle of elevation of the top of the tower is 60 degree. So when I say the angle of elevation is 60 degree, I have to consider it with regard to horizontal line. So this is the angle of elevation, which is 60 degree. And the angle of depression of the bottom of the tower is also given, and that is 45 degree. So this is 45 degree. This is 60 degree and this is 45 degree. we have to find the height of the tower when it is given that the height of the building is 7 meters. So let us name these points. So we have to find CE, that is the height of the tower. And what is given? We are given AB, that is 7 meters. And we are given two angles here. Now clearly the building and the tower, they both are standing erect. So they are at 90 degree to the horizontal. So I can say that these two are parallel lines. Similarly, these two are also parallel lines because this is the horizontal line, so it is parallel to the ground, which is the horizontal level, of course. So this is a parallelogram, so opposite sides will be equal. So I can say that AB will be equal to DC and AD will be equal to BC. This we will use through the question, and AB is equal to DC is already giving us that DC will come out to be equal to 7 meters, right? So now let us apply trigonometry to find this part, that is DE. But for finding this part, if I applied trigonometric ratio in this triangle, this is 90 degree of course, if I apply it in this triangle, I should need some other length also. At least one of the sides of this triangle should be known. That is the only case where we can apply trigonometric ratio. Now how to find that part? Say we find AD. Now AD is equal to BC. This we have already written. So if we can somehow find BC, we will say that it is equal to AD, and then we can use the trigonometric ratio to find ED. So our strategy would be to start with finding BC. So here in this triangle, since we know that this is 45 degree, these two are parallel lines. If this is considered as a transversal, this is also 45 degree by alternate interior angles. So let us apply trigonometric ratio in triangle ABC. So in triangle ABC, I know AB, which is perpendicular with respect to 45 degree, and I want to find BC, which is base with respect to 45 degree. So perpendicular and base, they are related with the T ratio tan. So tan 45 degree is equal to perpendicular upon base, and in this triangle it is AB upon BC. What is the value of tan 45? It is 1. 1 is equal to AB upon BC. So we can say that BC is equal to AB. Now what was the value of AB? It is given to be equal to 7. So BC is equal to 7 meters. So I found this equal to BC, and I already stated that BC is equal to AD. So therefore AD will be also equal to 7 meters. Now let us move to this triangle. In triangle AED, I know that the value of AD is equal to 7 meters. I want the length of ED. So with respect to this triangle and this angle 60 degree, this ED which is unknown is perpendicular, and this AD which is known already, it is base. Now which trigonometric ratio connects perpendicular with base? That is tangent. So tan of 60 degree is equal to perpendicular upon base is equal to ED upon AD. Now what is the value of tan 60 degree? It is √3, and ED is unknown, AD is 7. So 7 √3 is equal to ED. But this gives us just the length of this part. We want the length of the whole tower, that is EC. EC comprises of two parts, ED and DC. So 7 √3 plus DC, which is already we know that it is 7. So here we get 7 √3 plus 1 meters. So this is the height of tower, that is 7 √3 plus 1 meters. Children, this was part 1 of some applications of trigonometry. In this part, we have recapitulated trigonometric ratios. We have also studied how trigonometry has been used since ancient times to find heights and distances. We have done a number of examples also from our real life where we have found heights as well as distances. We will continue doing this in the part 2 of the chapter. We will do some more examples and we will also recapitulate our knowledge with the help of some multiple choice questions. See you till then. Bye-bye.